Hi, this is Mrs. Rodriguez, your Algebra 2 teacher. This video is a review for the Chapter 13 quiz that's coming up. These questions are from a practice quiz that can be found in your textbook. What I suggest that you do is, as you're watching this video, is when a problem comes up on your screen, pause it. If you can solve the problem and get the correct answer, great, move on to the next problem. If you get a problem wrong, please listen to my explanation, try to figure out what your mistake was, and then hopefully you get any misconception cleared up. And then if you get to the end of the video and you still have a couple questions, please call, text, email me, or stop by my office hours before you take the quiz so I can answer all of your questions, okay? All right, let's go ahead and get started. Let me share my screen with you. All right, so this is the review for the Algebra 2, Chapter 13 quiz, and the problems are from page 892 of your textbook. Okay, so problem number 2 says to simplify each expression. Okay, so this chapter is all about trigonometric identities and equations, and we're just going to be going over the first half of the chapter. We're not going to worry about the second half. Okay, so here we go. So we have 1 minus cosine squared theta over sine squared of theta, and 1 minus the cosine squared of theta is equal to sine squared of theta, and that is from page 873, the Pythagorean identity. Okay, so we're looking for an equivalent expression here, and so 1 minus cosine squared of theta is equal to sine squared of theta. So I would put sine squared of theta, and then my denominator is also sine squared of theta, and so sine squared of theta over sine squared of theta is equal to 1. It's as if we had 7 over 7, right, is equal to 1. Same thing here, okay? So basically what we're doing is these are like fractions, right? This is a fraction bar, and we're trying to simplify them or rewrite these one or both of the expressions in order to simplify them as much as possible, okay? All right, so next problem says 1 over cosine theta minus sine squared of theta over cosine of theta, okay? So here we are subtracting two fractions with the same denominator, okay? So the denominator is going to be the same, and we would subtract the numerators. So we have 1 minus sine squared of theta, okay? All right, so then 1 minus sine squared of theta is equal to cosine squared of theta, okay? So now this expression, and then again, this is another Pythagorean identity, and this expression becomes cosine squared of theta over cosine of theta. Our denominator stays the same. Now this is like having x squared over x. We could factor out an x and simplify. So here we would be left with x, and here we'd be left with 1. So here we could factor out one of the cosines. So we're left with cosine theta, and then here we're left with 1. So we have cosine theta over 1, which is equal to cosine of theta. And that is as far as we can simplify. Okay. So trick here is getting these Pythagorean identities. And again, these are on page 873. Okay. And then finding equivalent expressions there in order to simplify. Okay. All right. So number 6 says find the value of each expression. So it says sine of theta if cosine of theta is equal to 3/5. Okay, and theta is between 0 and 90 degrees. Okay, so we have sine and cosine. So we're going to use the Pythagorean identity. So we have cosine squared theta plus sine squared theta is equal to 1. That is what the Pythagorean identity states, okay? So then we're going to subtract cosine squared of theta from both sides, because this is an equation. We can do that. Whatever you do to one side, you have to do to the other. So now we have sine squared of theta is equal to 1 minus cosine squared of theta. Okay, so you might be asking yourself, well, why did we subtract cosine squared and not sine squared? Well, because we're given cosine of theta. Okay, so then what we can do is substitute in for cosine. This is cosine squared. We're going to substitute in for theta 3/5. Okay, and over here we still have sine squared. Sorry. So here we would put in, for cosine theta, we would put in 3/5, and we're squaring that. Sorry, you shouldn't have the cosine in front there. Okay, so then we have sine squared of theta here, and then 3/5 squared, well, that's 3 times 3, which is 9, and 5 times 5, which is 25. Okay, so we've got sine squared of theta. 1 minus 9/25. Well, 1, we want our denominators the same, right? So 1 we can rewrite as 25 over 25. And we keep our denominators the same. We subtract our numerators. 25 minus 9 is 16. So this is sine squared of theta. And then we want sine of theta, so we would take the square root of both sides, okay? So then we would have sine of theta is equal to the square root of 16, which is 4, and the square root of 25, which is 5. So sine of theta would be 4 over 5. Okay. All right. Next problem says, it's very similar. It says wants you to find cosecant of theta if cotangent of theta is 1/2. And this is when theta is between 270 degrees and 360 degrees. So now we're going to use the Pythagorean identity. Okay, and this is, since we have cosecant and cotangent, we're using cotangent squared theta plus 1 is equal to cosecant squared of theta. Okay, and these again are on page 873 of your textbook. Okay. All right, so now we're going to substitute. We're given cotangent of theta is equal to 1/2. So I'm going to replace cotangent with 1/2 squared plus 1 is equal to cosecant squared of theta. Okay, so 1/2 squared, 1 times 1 is 1, 2 times 2 is 4, plus 1 equals cosecant squared of theta. So 1/4 plus 1 whole, so 1/4 plus 4 over 4. So we keep the denominators the same and add the numerators. So 5/4 is equal to cosecant squared of theta. And now remember, we want cosecant of theta, not cosecant squared. So we would have to take the square root of both sides. So the square root of 5, we're going to leave it as the square root of 5, and the square root of 4 is 2. And then that would be the square root of cosecant squared is just cosecant. Okay, and we do not need to simplify this anymore. If we had it, if in the denominator we had the square root of 5, then we would have to keep simplifying, but our denominator is 2, so we can just stop there. Okay. All right, number 11 says to verify that each of the following is an identity, okay? So in other words, make sure that this side is equal to this side, okay? So first we have cotangent squared of theta plus 1 is equal to cotangent theta over cosecant times sine of theta. So first thing, cotangent squared of theta plus 1 is the Pythagorean identity, and it's equal to cosecant squared of theta, okay? And then we still have over here cotangent theta over cosine theta sine theta, okay? All right, and then cotangent, okay? Cotangent, what's up here, of theta is equal to the cosine of theta over the sine of theta. And this is the quotient identity, okay? Quotient identity. Again, this is page 873, okay? Page 873 of the textbook, this is where all the identities are, okay? So that means we're going to have, we're going to replace cotangent of theta with this, okay? So we're plugging this in here. So we have cosecant squared theta is equal to cosine theta over sine of theta, and that's being divided by cosine of theta times sine of theta, okay? So what we end up with is we're going to divide. So this, the first fraction stays the same, sine theta, and we're going to multiply by the reciprocal. Okay, so the cosine theta times sine of theta over 1, the reciprocal would be 1 over cosine theta times sine of theta, okay? And over here, we still have the cosecant squared theta, okay? So now I can see that I can cross simplify here. I have cosine of theta over cosine of theta, so that's equal to 1. And then I've got 1 times 1, and then sine of theta times sine of theta is sine squared of theta. And over here I still have cosecant squared of theta. And cosecant squared of theta is equal to 1 over sine squared theta. So 1 over sine squared theta is equal to cosecant squared theta. Again, this is another Pythagorean identity. So they're equal to each other, okay? So yes, these are identities, okay? Because they end up being equal to each other, okay? All right, and then here, number 12, we have cosine of theta times cosecant of theta over cotangent of theta, and we're going to see if that's equal to 1, okay? So I can rewrite cosine of theta times, instead of cosecant of theta, that's cosecant of theta is equivalent to 1 over sine of theta, okay? And then cotangent is equal to 1 over tangent of theta, okay? So I can rewrite this. I'm dividing these fractions. So I have cosine of theta over sine of theta, right? Cosine of theta times 1 over sine of theta, okay? And then I'm going to divide by 1 over tangent theta. So I keep the first fraction. I flip the second fraction, and I change division to multiplication, okay? So then this is equivalent to, so I've got cosine of theta over sine of theta, and tangent of theta is that quotient identity is equal to sine of theta over cosine of theta, okay? So I just rewrote tangent theta as sine of theta over cosine of theta, and I'm multiplying, okay? So then at this point, I can cross simplify cosine theta over cosine theta, sine theta over sine theta. Well, I've got 1 times 1 is 1, 1 times 1 is 1. And 1 divided by 1 is equal to 1, which is equal to 1. So yes, this would be an identity here, okay? All right, and number 20 says to find the exact value of each expression. So we've got the cosine of 105 degrees, okay? So on page 886 of your textbook, it talks about the sum and difference identities. Sum and difference identities, okay? So we're going to break this down, the 105 degrees, okay? So, because we have this identity that the cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B, okay? So we're going to break down 105 into 60 plus 45, okay? So we've got the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. Okay, so if you look on page 809 of your textbook, there's the trigonometric values for special angles. So it tells us on that page, there's a little chart at the bottom, tells us the cosine of 60 is equal to 1/2. The cosine of 45 is equal to radical 2 over 2. And it tells you the sine of 60 is equal to radical 3 over 2. And then the sine of 45 is equal to radical 2 over 2. Now, these are all on page 809. There's a chart there. I don't expect you to have these memorized, okay? All right, so now we simplify. Here, we're multiplying these fractions. So we've got 1 times radical 2, so that's radical 2, and 2 times 2, which is 4, minus 3 times radical 3 times radical 2, which is radical 6, and 2 times 2, which is 4. Okay, so then I've got my denominators are the same, so I'm just going to subtract my numerators. Radical 2 minus radical 6, and I keep my denominator the same. So the cosine of 105 degrees is equal to radical 2 minus radical 6 over 4. Okay. All right, and then here, similar problem, but this time it gives a degree measure to in radians. So this is what is the exact value of cosine of theta, of cosine 5 pi over 12. So since it's just like the problem we just did, except this is not in degrees, what I would do is just change it to degrees. Okay, so I've got 5 pi over 12, and I'm going to multiply that by 180 over pi to change it to degrees. So simplify pi over pi, and then 12 and 180 have a common factor of 12. 12 goes into 12 once, and 12 goes into 180 15 times. So I've got 5 times 15, which is 75, and then 1 times 1, which is 1. So this is 75 degrees, okay? So then I've got the cosine of 75 degrees. That's what I'm looking for. So I'm going to use that sum and difference identity. So I have, I'm going to use the cosine of A plus B is equal to cosine of A times cosine of B minus sine of A times the sine of B. And I'm going to plug in my values. So I'm going to use, for A and B, I'm using 30 and 45. So the cosine of 30 times the cosine of 45 minus sine of 30 times the sine of 45. Okay, so again, if you look on page 809 of your textbook, we have that chart. Okay, so and it tells you the cosine of 30 is equal to radical 3 over 2. The cosine of 45 is equal to radical 2 over 2 minus sine of 30 tells you is equal to 1/2, and the sine of 45 is equal to radical 2 over 2. Okay, so then I multiply radical 3 times radical 2, it would be radical 6. 2 times 2 is 4. And then 1 times radical 2 is 2, and 2 times 2 is 4. So I'm going to subtract my numerators, radical 6 minus radical 2, and keep my denominators the same. Okay, so the cosine of 5 pi over 12 is equal to radical 6 minus radical 2 over 4, okay, which is h in this case, okay? All right, so thank you so much for watching. Hopefully this video was helpful to you and answered a few of your questions. I know this was a challenging couple of lessons here. Okay, so if you still at this point have any questions, please call, text, email me, or stop by my office hours, and I'll be happy to help you. Okay, have a great day and good luck on your class.